Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Wulan with ID number 8241230008. And at this time, I will explain to you about sound in physics. Okay, sound is an important part of existence for many living things. Animals can use sound to hunt, attract mates, and warn of the approach of predators. In humans, the sound of a siren can heighten our awareness of our surroundings, while the sound of music can soothe and relax us. From your everyday experiences, you already are familiar with several of the characteristics of sound, including volume, tone, and pitch. Without thinking about it, you can use this and other characteristics to categorize many of the sound that you hear. For example, some sound patterns are characteristic of speech, while others are characteristic of a musical group. In this chapter, you will study the physical principle of sound, which is a type of wave. Okay, um, sound waves. Sound wave is a pressure variation that is transmitted through matter. Sound waves move through air because a vibrating source produces regular variations or oscillations in air pressure. The air particles collide, transmitting the pressure variation away from the source of the sound. You can see the sound waves at this picture. Okay, next, the frequency of the wave is the number of oscillations in pressure each second. The wavelength is the distance between successive regions of high or low pressure. Because the motion of the particles in air is parallel to the direction of the wave's motion, sound is a longitudinal wave. Next, detection of pressure waves. Sound detectors convert sound energy, the kinetic energy of the vibrate in air particles, into another form of energy. A common detector is a microphone, which converts sounds waves into electrical energy. A microphone consists of a thin disc that vibrates in response to sound waves and produces an electrical signal. The human ear, as shown in figure, is a detector that receives pressure waves and converts them to electrical impulses. Okay, sound waves entering the auditory canal cause vibration of the tympanic membrane. Three tiny bones then transfer these vibrations to fluid in the cochlea. Tiny hairs lining the spiral shaped cochlea detect certain frequencies in the vibrating fluid. These hairs stimulate nerve cells, which send impulses to the brain and produce the sensation of sound. The ear detects sound waves over a wide range of frequencies and is sensitive to an enormous range of amplitudes. In addition, human hearing can distinguish many different qualities of sound. Knowledge of both physics and biology is required to understand the complexities of the air. The interpretation of sound by the brain is even more complex and it's not totally understood. Okay, next, perceiving sound. Um, First, pitch. Marin Mersenne and Galileo first determined that the pitch we hear depends on the frequency of vibration. Pitch can be given a name on the musical scale. For instance, the middle C note has a frequency of 262 Hz. The ear isn't equally sensitive to all frequencies. Okay, second, loudness. A frequency and wavelength are two physical characteristics of sound waves. Another physical characteristic of sound waves is amplitude. Amplitude is the measure of the variation in pressure along a wave. In humans, sound is detected by the ear and interpreted by the brain. We can see in this picture, um, Because humans can detect a wide range in pressure variation, these amplitudes are measured on a logarithm scale called the sound level. The unit of measurement for sound level is a decibel. The sound level depends on the ratio of the pressure variations of a given sound wave to the pressure variation in the most faintly heard sound. 2 times 10 to the power of minus 5 Pascal. We can see in this figure. Um, for this decibel scale shows the sound levels of some familiar sounds. At 10 decibel is barely audible, and 30 decibel whisper 1 meter away, 50 decibel casual conversation, 70 decibel heavy traffic, 80 decibel alarm clock, 100 decibel siren, 110 decibel rock concert, and 140 decibel jet engine. Okay, next, the Doppler effect. Have you ever noticed that the pitch of an ambulance, fire, or police siren change as the vehicles sped past you? The pitch was higher when the vehicle was moving towards you. Then it dropped to a lower pitch as the source moved away. This frequency shift is called the Doppler effect and is shown in figure. A Doppler shift also occurs if the detector is moving and the source is stationary. In this case, the Doppler shift results from the relative velocity of the sound waves and the detector. Okay, at this figure, we can see that the sound source S is moving to the right with a speed of Vs. The waves that it emits spread in circles centered on the source at the time it produced the waves. As the source moves toward the sound detector, observer A in figure 15.6a, more waves are crowded into the space between them. The wavelength is shortened to A because the speed of sound isn't changed. More crests reach the ear per second, which means that the frequency of the detected sound increases. When the source is moving away from the detector, observer B in figure 15.6a, the wavelength is lengthened to B and the detected frequency is lower. Figure 15.6b illustrates the Doppler effect for a moving source of sound on water waves in a ripple tank. A Doppler shift also occurs if the detector is moving and the source is stationary. In this case, the Doppler shift results from the relative velocity of the sound waves and the detector. Okay, next, the Doppler effect. This is the formulas. The formulas is Fd equals Fs times V minus Vd divided by V minus Vs in bracket. The frequency perceived by a detector is equal to the velocity of the detector relative to the velocity of the wave, divided by the velocity of the source relative to the velocity of the wave, multiplied by the wave's frequency. In the Doppler effect equation, V is the velocity of the sound wave, Vd is the velocity of the detector, Vs is the velocity of the sound source. Fs is the frequency of the wave emitted by the source, and Fd is the frequency received by the detector. This equation applies when the source is moving, when the observer is moving, and when both are moving. Okay, maybe that is what can I explain to you about sound in physics. Thank you very much for your attention. I'm Wulan Charisa. I hope this explanation video can help you to understand about sound in physics. Okay. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.